Hey everyone, today's topic is going to be on multiple things actually. So firstly we're going to do alternating series, and then after we do alternating series we will also be doing Taylor/Maclaurin series. So this is essentially going to just be everything that's left combined into one video because I realized that this would be a lot easier and faster. Okay, let's get started. So an alternating series, the alternating series test is a very simple one and basically states that you're going to have a series where n equals some value, right, to infinity, and then you're going to have this or some sort of negative that alternates. So you have to have some negative. It could even be a number. This is an alternating geometric series, for example, to the n, where you have a negative that's going to be alternating. Whether it's n plus 1, or there's an n up here, and this could be 2n plus 1. Doesn't really matter. The point is that this is going to give you some sort of alternating series. This possibly will give you some sort of alternating series, as long as, to some extent, you can derive this from it. Some sort of negative 1 to the power of n, or negative 1 to the power of n plus 1. All right, so when you have these conditions, what it's essentially going to give you is point where you have a term that's positive, term negative, term positive, term negative. So you may have something that's like 1 minus 2 plus 3 minus 4 plus 5, etc. into infinity. And then you may ask, oh, well, what's this answer to this? Well, it's pretty simple, actually, because you just have these combined to be negative 1, this is negative 1, and these are negative 1. So you should have negative 1 adding to infinity. So eventually you're going to have some value near negative infinity from that. So that diverges. So how do we determine whether or not these converge or diverge? Well, by the alternating series test, it's pretty simple. There are three conditions for it. So the first is that a of n is greater than 0. And the reason for that is if you have this, and this is less than 0, that means that you have some negative value a of n, or everything else might be negative, which means that it's going to throw off this negative sign, and then you don't really know whether it's going to be positive or negative, or constantly decreasing, or constantly increasing, or who knows. If you can take a negative out of this, you might actually have something like this, where these two cancel out and it's just a positive series. So a of n has to be less than 1. Second condition is that a of n has to be decreasing. So if you have something like this is a geometric series, this is going to be increasing. A of n is going to be increasing as n increases. But if you have something like this, then it's going to be decreasing. If you have a condition that you're not sure of, maybe you have something crazy like e to the x over 7x plus 3 or something, something crazy like that, then what you might want to do is find the radius of convergence. So limit as n progresses to infinity of whatever your thing is. So n of plus 1 and then n here. And then you just do that. We went over that in a previous video, so I don't think I'll go over it here. So it has to be decreasing each time. Right, so the radius of convergence has to be less than 1, aka decreasing. And the limit as n progresses to infinity of a of n has to be equal to 0. So, to infinity of a of n has to be equal to 0. So basically what you do is, if I have something like 1 over 2 to the n, right, as n progresses to infinity, this will eventually be 1 over 2 to the infinity, obviously, which is increasing faster, 1 or 2 to the infinity, 2 to the infinity. This is going to be infinitely more large than that, so it's going to converge to 0. You learned that in calculus last year. So that's basically the alternating series test, just combining everything together. And the reason I'm going so quick is because we want to go over Taylor and Maclaurin series. So Taylor and Maclaurin series are the same thing, except Maclaurin series is centered at 0. So when you have a graph, you can create a Taylor series to model how accurate an accurate representation of this graph, and the center will determine where you start. So if I have a center at 1, let's say, oh, this isn't 1, this would be 1. I'll say, at 2 pi right here, or actually, no, this would be pi. Wait, what would this be? This would be 3 pi over 2. So this would be 3 pi over 2. Let's say we start at 3 pi over 2. Well, if we start at 3 pi over 2, then one-term series may look like this. Or actually, technically a tangent line. And then a 2-term series would look like this. And then a 3-term series would look like this. And then a 4-term series would look like this. And then eventually you would closer and closer model the entire curve. And if you have an infinite amount of terms in the series, you will actually get an equivalent model to the sinusoidal curve. Okay, so that being said, when you're constructing a series, a Maclaurin or Taylor series, Maclaurin series is just centered at 0. And when you're constructing these, let's say you want to construct the one, let's do the one for sine of x, centered at 0. What you'll have is, this is a value called a, your center is called a. And what you'll have here is f prime of a, you'll have 3 terms per term of your Taylor series. So the Taylor series of some function given x, your center of x, is going to be, not your center of x, your value of a, is going to be f to the n of a times x minus a to the n divided by n factorial. So f of your 0th term, or technically your first term, but your 0th term, f of 0 is just going to be the original function. N of your first term 1, or second term, is going to be the derivative of this, and x minus a to the 1. And then you go all, you'll have this all the way into infinity. So you'll have an infinite amount of terms at the end. So let's say you want to get a fifth, or let's do a third degree polynomial for, a third degree Taylor function for sine, right? So here's what we'll do. So let's first of all take all the derivatives of sine. So the original function of sine of x is sine of x. The first derivative is cosine of x, and the third derivative, negative sine of x. First derivative, second derivative, third derivative is negative cosine of x. There we are. All right, cool. Now what we're going to do is, let's make all our terms. All right, let's say our center is 0. Well, x minus 0 is just x, right? So we'll just have that centered at 0. And then what we can do is just say, all right, we have sine of x times x to the 0 over 0 factorial. 0 factorial is 1, by the way. So we have sine of x times x to the 0, which is just 1. And then sine of a, don't forget, sine of a, or in this case our a is 0. So we have sine of 0 times 1 over 1. What's sine of 0? Well, if you look at a sine curve, it's 0. So that means that our first term is just 0. It's non-existent. All right. Let's look at the next term. All right. So the derivative, we take the first derivative, cosine of 0, right, because that's a, times x to the first power, right, over 1 factorial, and 1 factorial is just 1. Cool. So we have cosine of 0 times x. What is cosine of 0? Cosine of 0, well, it's 1. So we have 1 times x. So our first term is x. Great. Now our next term, all right, we have negative sine of x. So we have negative sine of x, or in this case, sine of a, which is 0, times x squared over 2 factorial, which is just 2. All right? So sine of 0 is just 0. So that means this whole thing is 0 and it doesn't exist. And you're starting to see a pattern here where only every other term exists. And this is true for cosine as well. Every other term exists. So negative cos, so our third term, negative cosine of a, which is 0. We already know cosine of 0 is 1. So we'll have minus x to the third over 3 factorial. And 3 factorial is, remember, 3 times 2 times 1, which is 6. And this goes on. It turns out sine of x has an alternating series. So you can actually model this as an alternating series, and they'll often ask you to write this out. So you have your first term, 0th term doesn't exist. You have x over 1 factorial minus x to the third over 3 factorial, add 2, plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. And they might ask you to write this out, and then to write the general term for the series. So the general term for the series is basically going to look something like this. All right, we have that, dot, 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 and then the sum, and then just kind of observe it. So we know that we're going to have x to the 2n plus 1, when n is equal to 0, to infinity, over 2n plus 1 factorial. And we know, and it's an alternating series, so we have negative 1 to the n. So n of 0 negative 1 to the 0 is just 1. So 1 times x times 0 plus 1, so times x. So 1 times x over 1 factorial, first term. Second term, negative 1 to the 1, which is just negative 1, times, what's that? 2 plus 1, which is 3, over 2n plus 1. Oh, n is 1. 2 plus 1 factorial, which is 3 factorial. X to the third, negative x to the third, over 3 factorial. So as you can see, you just have this general term that really comes from observing your function. If you would like to practice, do me a favor and just do the same with cosine, and then you'll see the same pattern emerge. And if, let's say you have your center now at, I don't know, 3. All you need to do is replace x with x minus 3. So I just go in and say x minus 3 to the first power, x minus 3 to the third power, x minus 3 to the fifth power. And that would be your new center. That would move your function over to now over here to around wherever 3 is. Or in this case, pi is about 3, so you'd assume that it's somewhere around here. Oh no, around here, because this is where pi is on a sine curve. Alright, so I hope that helps everyone, and I hope, now that this is our last video, that you do well on the AP exam. Best of luck, and let me know if you need anything else.